Welcome everyone to the Stencil workshop. My name is Mike Hartington. I'll be the instructor for this session. If you have any questions afterwards or want to reach out, you can follow me on Twitter at mhartington. We're going to go over Stencil, the cross-framework component compiler, and dive in deep into what the compiler can offer and why you would want to use it. So let's answer that first question. Why would you want to use Stencil? Let's answer that by looking back at where we came from in the web. So a long time ago, we started to see components appear on the web. Now, these were components in air quotes coming from different frameworks that were providing their own solutions to creating reusable pieces of logic that developers could install on their project or link to a JavaScript file in their HTML and instantiate on their own. Now, these are very much driven by the needs of their time. So, as we go through and look at some of these examples, keep in mind that they were all created during a certain time period. But components in general on the web started off with this little library that I'm pretty sure that we all are aware of, jQuery. Now, jQuery itself was pretty unique in that instead of giving you a component definition to define your components and set everything up that way, they gave you this $fn object. Now, this allowed you to map in your own custom functions onto the jQuery prototype. So in our example, we have $fn.helloworld, and it's going to equal a function. Inside of our function, we are going to append an h1 with the text hello world, and then we can invoke that by passing in an element and then calling hello world. Now, this function could be called anything that we want, but the important part was that we weren't recreating everything from scratch. We had some kind of base that we could extend. Backbone took this a step further by giving us a way to create some kind of component or some kind of view or representation of HTML, and then be able to recreate it multiple times by either passing in different targets and giving us some standardized methods that we could use to initialize our views. So in here, we have this variable of app view, and this is going to be a backbone.view.extend, really building on top of that extending an existing object. Here, initialize is a function that comes from the backbone view base, meaning that we didn't have to create this or call it ourselves. All we had to do is declare it, and it will automatically be invoked once we new up our component. So inside of initialize, we're just going to call this.render. And this.render is going to be a function where we take the element that we pass in and set the HTML to be hello world. Now, to create a new app view, we just say new app view, and then we can pass in the element as our target. And this is using jQuery. So we can pass in a jQuery selector to start to build up our functionality and create reusable bits of logic inside of a bigger application. Now, these concepts aren't the only two that ever existed. There's dozens of other libraries and frameworks that could be referenced here as starting points for where components came from. But these ideas of creating some reusable component using existing bits of code as a base really paved the way for everything that we see coming from frameworks today. In Angular, we have this concept of using decorators, classes, and being able to declare our component in some sort of HTML fashion and have them exist using a higher level abstraction. In our hello world for Angular, we use @component and then provide the selector or the element that we want to actually use when we render this. The template is just some HTML that we're going to render out, which is a div and an h1 of hello world. And then we could even supply our own styles using the style URLs array. And then if we want to add some kind of custom logic to this component, we could start creating methods on top of this app component class. Once we're ready, we attach it to a module, and then we can bootstrap that module inside of our app. React takes a slightly different approach by saying everything is just JavaScript, and we create a representation of our HTML using JSX. So in our React example, we have a function called app, which returns a representation of our HTML using JSX, where we have a div and then a h1 saying hello world. Now to bootstrap this or render this, we just get a hold of a root element, and then we call react dom.render, passing in our component as a JSX tag, and then the root element where we want to render this. And then finally, wrapping up the big three, we have Vue, where they take the concept of components and simplify it into a single file format. Here we have a template tag, where we are saying that our template or our HTML for our component is going to be declared inside of these template tags. We have these script tags, which will house the logic for our component, and then these style tags, which will hold the CSS for our component as well. These are all encapsulated together, so there's no way of leaking the styles and having some sort of conflict between different components. When we want to actually render this to the screen, all we do is grab a hold of some root element, and then we render this app component to that root node. Now, I said that this was the big three and that there are dozens of other libraries or frameworks that people can use. A few of them are here in this list, but this is a non-extensive list. If we were to go on, say, Hacker News or some other website that lists out all of the different frameworks, we're going to see an even bigger list of frameworks or libraries out there. And this is overwhelming. Frameworks keep reinventing this idea of custom components and custom UI, but do it in a way that is isolated from one another. Meaning that if I create a component library in Angular, I'm only going to be able to use it in Angular. Same thing in React, and same thing in Vue. There's no easy way to share these components across different frameworks or in an environment where no framework is necessary. But what if there was an easier way to do this? What if there was a way to create our components in a standardized syntax that works in all the major frameworks and can even work in an environment where no framework is needed? This is web components. Now, if you've heard of web components before, you probably have some preconceived ideas, but let's go over the basics. Web components is an umbrella term for a collection of different standards that define how we can create standard-based, reusable components. The major APIs at play here are the template API, allowing us to create inert pieces of DOM that we can just constantly clone, not having to recreate HTML over and over. The custom elements API, which allows us to create our own tags and define the functionality within that tag. And then Shadow DOM for creating encapsulated bits of DOM structures that are not exposed to the public-facing light DOM. Now, these APIs were designed to work in a way that they could integrate well with all the major frameworks out there, as long as they are following standard JavaScript practices. And if you want to see a list of frameworks that support custom elements, you can go to customelementseverywhere.com to see a list of major frameworks and their support for custom elements. If you've also heard of custom elements or web components before, you might be thinking, is this a Google or Google Chrome thing only? No, this is actually supported in every major browser. Safari, Chrome, Edge, Firefox, all the major browsers out there, and some of the variant browsers from Chromium to Gecko and WebKit all support custom elements. You might also be thinking, is this something called Polymer? I've heard about this before. Is this the same thing? And it's kind of close. Polymer is a polyfill for web components to allow you to write some sort of web component-like API, and it will polyfill the browsers that do not support custom elements. So to see what a web component actually looks like, let's look at a vanilla example. Here we have a component called Hello World. It's just a class, and it's going to extend the base HTML element, an idea that we saw back in Backbone, where we're extending a built-in object. Now, when our component gets inserted into the DOM and everything is ready to render, we have this connected callback method. This is automatically called for us just by extending HTML element. So what we'll do is call this.attachShadow, passing in the mode open. This is going to create a shadow root for us where we can encapsulate the internals of our component. From here, we can call this.render and start to add new HTML to our shadow root. Now, attach shadow and this.shadow root are all things built in to HTML element that we are getting for free. Now, to tell the browser about this component and what tag to use, we can call customelements.define, passing in a hyphenated tag name. Now, the tag name needs to be hyphenated as part of a standards compliant way of saying this element tag is not browser defined, but user defined. And to tell the browser about the custom elements implementation, we can pass in a class reference. Now, our custom element here doesn't really do a lot, so let's look at a more complete example. Here we have a component called BetterImage. This is a component found on GitHub at github.com/perlbay/better-image that builds on top of the existing image element and adds a few niceties. For example, we can start to supply an URL and then a fallback URL in case the image fails to load. Inside of the index.html, we have our better image tag with the URL pointing to the placeholder image API. If for some reason we forgot to add in the first T for HTTP, we can fall back to a different image that will be able to supply some sort of placeholder. If the image doesn't fail, then we won't even request the second image and we'll still be able to have a good experience. Now, you can review that better image component, but you might notice a lot of different things that feel lacking. For instance, if we were to try to update our properties or update any attributes on the component, they're not going to be optimized. So if we change one and then it updates, and then we change another and then it updates again, there's no way to batch out these operations so we were doing one read and then one write. The properties also aren't smart. We need to manually watch for those changes and then react to them whenever they change. For our better image example, inside of the component, there is an image tag that we need to constantly keep track of what the source is in order to be able to supply the real URL and then the fallback URL in case the first one fails. Generally speaking, web components are great, but they are very low level, and that's kind of by design. This is where Stencil comes in. Stencil is a compiler for web components. You write in this higher level syntax that generates web components after you run a build. Now, Stencil doesn't try to recreate the wheel in another way that is unique from any other framework. We actually borrow a lot of ideas and concepts from different frameworks. One of the big ones is the concept of decorators and JSX. So as we look into our workshop and look at some of the examples, we'll start to pull out different decorators that allow us to augment our component and start to add more functionality. We also include things like JSX and a small virtual DOM for speed, meaning that as we start to author out our components and the internal templates, we can know that the updates are going to be batched out and compared against the real DOM before actually updating. So updates are going to be fast and stay fast. Most importantly, Stencil is not a framework, nor does it try to be. Stencil's sweet point is where you create a custom library of components for your organization. You can start to build out those components in a consistent cross-framework approach, And as you need to support other frameworks, you can start to generate specific bindings for those frameworks instead of having to rewrite your components. Let's start to dive into Stencil. Before we get started, we'll need to make sure we have a few tools already taken care of. First off, we'll need to have a editor set up and installed that can support TypeScript. Chances are you should probably be using VS Code. Other editors like WebStorm, Atom, Vim, Emacs, if you want to be those people, also work. Just make sure that you have your TypeScript support already enabled. You'll also want to make sure that you have a semi-recent version of Node. Anything LTS or greater will work. With all the prerequisites taken care of, let's create our new project by running npm init stencil, and then select the component starter kit. For our project name, we can just call this TSConf, and then confirm. Now, once we picked our project, the toolchain will automatically be downloading the scaffolding that we need in the background. So as soon as we add in our project name, we're ready to go. Let's cd into the directory and run npm install or yarn install. From here, we can open up our editor and then open up our file explorer to take a look at the project structure. Now, aside from the usual suspects like an editor config, prettier RC, and our package lock and package JSON, the main thing that we'll want to look at is our Stencil config, which sets up our entire project configuration. Now, for our config, the main things that we'll want to look at are these output targets. Stencil provides a few different output targets, which allow us to take our components and create different bundles or different distributions of that code. For example, the first output target is the dist output, which is the typical way you would ship your components for consumption. If your component library ends up being multiple components, instead of having to include a reference to every single component, you can include one reference to this loader file, which will understand how to lazily load all of our components as they're requested. This is the simplest way to bundle your components, and this is how we do things inside of Ionic. The second entry that we have here is for bundling all of our components as individual bundles. So if we have multiple components and we want to make sure that we maintain the smallest bundle size possible, and we're not using the built-in lazy loader, we could import these components one by one. That way we have more fine-grained control over how these components get loaded and when and where they get bundled. The next output target is for the documentation. Stencil includes its own documentation generator, so as you start building out your components and adding the appropriate type information, we can extract all that information into a docs file. That way you can have some self-documenting components. Then the final output target is the www type. This is very useful for doing some testing of your components, so that way you can inspect them in the context of an HTML page. Or if you want to generate, say, a landing page or a documentation page, you could use the www type to generate all that. By default, we disable creating a service worker, but you can also change this to enable a service worker and have offline versions of your docs. Moving on, we have our TSConf. This allows us to configure the TypeScript compiler for our project, as well as set the JSX type and JSX factory. So we will be using JSX to author our components. If you have never used JSX before or just want a quick refresher, take a look at the React docs. They have a whole section introducing JSX and going over all the key concepts of it. Back inside of our TSConfig, we have our includes array, which includes the source directory, which is where we'll be spending most of our time building out our component set. If we open up the source folder, we'll see a folder for components, utils, a definition file, our index.html, and an index.ts. The index.ts will be our main entry point. The index.html will be used during the dev server and during the www output target. The components.d.ts file will be used to generate the proper types for our components. Utils is obviously for utility functions. And then the component itself is listed in components as my component with a mycomponent.css, an end-to-end test file, a spec test, and then the component itself. Before diving into our component, let's open up a new terminal window and then run our dev server with the command npm run start. If you're using Yarn, this would just be yarn start. Now, the first thing that you'll notice is that our dev server starts incredibly fast and that the build has completed in 1.26 seconds. We'll open up our browser window to localhost 3333, and we will see hello world. I'm Stencil. Don't call me a framework. JS printed out into the browser. Back in our component, we'll start to break down how this component gets rendered and how this component takes the bits of information that it's provided to generate that text on the screen. Let's close the file tree, and we'll start off with our import statements. So we have 3 imports from Stencil core, bringing in the component import statement and prop, and then H. Now, component and prop are decorators provided by Stencil that allow us to write our component in a higher level syntax or a higher level API than we would if we were to, say, author web components using vanilla JavaScript. H in this case is our JSX factory, which we need to import and provide to all of our components. So that way TypeScript understands that we're writing JSX, and then this is going to be the factory function that will generate all of our DOM. We'll look at format in a little bit, but we'll first stop at this @component decorator. Now, as we said in the import statements, @component is a decorator, which is just a function that gets added atop of our class to tell the compiler that this class is of a type component and provides some metadata to the compiler. In this case, we're saying that this component, when it gets generated, is going to have a tag name of my component. So we'll have a hyphenated tag name, which is part of the web component or custom element spec that we have to have a hyphenated component name. So we'll provide the my-component tag name as the proper tag that will get used when we want to render this out. Style URL will allow us to pass in a file of styles that we want to bundle with this component. We'll look at mycomponent.css in a little bit. All that we need to know is that at build time, it will take the contents of that CSS file and make sure that it is incorporated into this component in a way that prevents the styles from being able to bleed out. And then finally, this shadow option that we have here is going to tell our component that we want to generate shadow DOM. Essentially, we want to take all of the DOM structures that we're going to generate from our component and encapsulate it in a shadow root. This will allow us to safeguard our component so that way no one can target it with their CSS or query any of the internal nodes with JavaScript. Now, inside of our component, we have just a standard class, which is just going to be called myComponent. And then we have our very first app prop decorator. Now, app prop is a special type of decorator which we supply to our class properties to let the compiler know that these are going to be things that users can set on the component itself. So instead of it just being a normal class property, we are just saying at the time of compiling this, there will be an element called myComponent, and that there's going to be an attribute named first that users can set. Now, it might be a little confusing to think of attributes and properties, but in Stencil's perspective, the concept is pretty much the same. A property or something that is decorated with this at prop is both an attribute on the element and a property on the class or the prototype at the same time. So there's no trying to figure out, is it a value attribute or value property? They're all the same and they're kept in sync at the same exact time. Now, things to note about class properties decorated with this at prop decorator is that one, when their value changes, they'll cause a re-render. So right now we have 3 props on our component for first, middle, and last. Anytime one of those values change, our component will automatically re-render. Second, anything decorated with at prop is immutable. So if we wanted to have a re-render get triggered by a change of at prop, so for the prop first, since it's a type of string, we couldn't modify the value that just uses the same string reference. We'd have to redefine the value to be a new reference or a new string reference. And third, anything with at prop should not be changed from within the component itself. This could lead to infinite loops where you're trying to render as something is changed, and then you potentially are changing it again and then constantly re-rendering. The data flow should be that data comes from outside of the component and gets set on the props, never changing the props internally. Now, there are some cases where these rules can be modified, but those are pretty unique and most people won't need to know what those are. Further on down the component chain, we have this very first private method of our class called getText. And all this is going to do is format and return the first, middle, and last properties of our component. So really all format does is just concatenate all these strings together and then returns that back to our component. And then finally, the main logic of our component is this render method, which returns some JSX, which is of a div saying, hello world, I'm printing out the value from getText, which is the formatted version of our first, middle, and last properties. Now, to get a better sense of how this all comes together, let's go to our browser. We'll bump the font size a little bit, and we'll open up our DevTools and start to inspect the component inside the DOM structure. So here we can see that we have the component selected. We can see that we are setting the first property to Stencil and that the last property is set to don't call me a framework JS. You'll also see that we have this hydrated class applied and that we have hydrated applied to the HTML as well. This is part of Stencil's way of understanding that when the entire DOM is ready to render, we can do a single paint. So that way we are not trying to render pieces as they come in and as they are ready. We can have a much smoother experience by just setting the hydrate class after we know that everything is ready, and then we can show all of our components. With our component selected, if we come down to the console and we type $0, we can start to see a reference of our component in the DOM, and we start to modify the component and watch the updates automatically get applied. So let's have our new first name, and you'll notice that as soon as we hit FI, the properties will autocomplete into the DevTools. So if we say our $0.first equals TSConf, and then $0.last, again, autocompletion shows up to show us the properties that we can complete. And we'll just say that the value is workshop. And let's go ahead and set a new property. This time we'll set middle, and we'll change that to Stencil.js. And we can say, hello world, I'm TSConf Stencil Workshop. So we can start to modify the internals of our component without ever diving into any framework aspects of it, and have these changes automatically be applied once we make them even in the browser's DevTools. Back in our editor, we can start to introduce other types of decorators to our component. The first one that we'll look at is the state prop. Now, if you come from a background in React, state should seem pretty familiar to you. Basically, all we do is say we have @state, and then we can define a class property that can also trigger a re-render. Here we've declared myStateProp as a type of string and decorated it with the @state decorator. So anytime myStateProp changes, our entire component will re-render and update the DOM. Now, you might be wondering, what is the difference between state and prop? State is internal to the component only. It does not get exposed to the component type and cannot be set from outside of the component. Prop gets exposed by the component type, and developers can set prop on the component itself. Developers consuming our components cannot set state. This is internal only. So a nice little way to think of it is, if we need to trigger a re-render but not expose this information, something should be set with @state. If we want to expose it, use @prop. So even though state isn't necessarily part of the component's public-facing API, we can still use it in our render function. So down here we say, hello world, I'm this.getText. Let's add a little bit more, saying, and my state is this dot myStateProp. We'll save this file, go over to the browser, and we can see, hello world, I'm Stencil, don't call me a framework JS, and my state is, without actually having anything set to state, we'll just render nothing. But we can mimic what this would actually look like by going up to our state prop and then setting a default value to some string. In this case, we'll just say foo. We'll save our file again, go back over to the browser, and we'll see state is foo. Another decorator that we can use is the watch decorator. Watch allows us to react to whenever a property or a @prop changes and manage the difference between the incoming value and then the old value. So if we wanted to watch for whenever the first prop changes, we can use @watch and then pass in the actual name of the property. So in this case, we'll watch for first, and then we can create our method on first changed. And then we'll get the new val, which will obviously be a type of string, and then the old val, which is also a type of string. And then we can just simply go console.log new, and then log out the new val, and then console.log old, and pass in the old value. With the component selected, we can go to our DevTools and we can say 0.first equals Mike. And then we can see the onFirstChanged method has been called, and we're logging the new value and then the old value, followed by the actual value confirmation coming from the DevTools. Now, watch is great for reacting to changes on our props from within the component. But if we want to expose this in a way that consumers of our components could use, we'd have to use a new decorator. To do this, we'll first import the event decorator, which is a decorator that wraps the custom event API, and we'll create an event calling it at event first name did change. Now we'll also type this to use event emitter, and then we can say what kind of data or what is this going to emit. In this case, since we're just going to emit the new value of the name, we will set the type to be string. And then we'll also go in and add the import from Stencil core. Now, to make use of this event, we can come down to our onFirstChanged method, and below the console logs, we can call this dot first name did change dot emit, and then we can pass in this dot first. So when the value changes on the component and the component reacts to it, we'll emit an event that says the first name did change, and this is its new value. So to test this out, let's first save our component, go to the browser, and with our component selected, we'll add an event listener for the first name did change event. So with this, we'll get the event, and then all we'll do is console.log first name did change, and then log out the event value. Now with our component still selected, we'll do $0.first, and we'll set the value to Mike again. We'll see the new value coming in from the onFirstChanged watch method. The old value, we'll see our new statement that we just created with add event listener. We're saying first name did change, and we're logging out the full custom event. If we expand this a little bit further, we can see all the expected pieces of our custom event, whether or not it bubbled, the detail, and also the source element and target element. So this is really just a custom event, the same kind of events that you would expect to get from a click event. So as we've gone through this, we figured out how to expose properties on our element, how to create internal states that can cause re-render, how to emit custom events, and how to watch for property changes on our component as well. What else can we do? Well, the next one that we'll look at is the method decorator. And a method decorator is pretty self-explanatory. It allows us to create a class method and then expose that method on our element. Let's say we wanted to create a custom method that would allow us to modify the internal state. To do this, we'd first create our @method decorator and then create the class method. For this, we can call it whatever we want. I'll call it pass in state, and it's going to get a value as an argument, and that value will be typed as a string. And all this is going to do is set this dot my state prop equals value. So by calling pass in state and then actually passing in a value, we'll redefine the my state prop, which will trigger a re-render. So let's save our file. We'll go to our browser with our component selected. We'll do $0 in state. Again, seeing that the method name is auto-completing inside of our DevTools. And then we will pass in a new value of bar, and then watch the state get updated in the component. And then we'll also see a return value from calling pass in state. Now, all class methods decorated with the @method decorator are executed as promises. Since Stencil's entire architecture is built around asynchronous styles of rendering your components, ensuring that all methods that are decorated with the @method decorator are asynchronous keeps that entire process in sync. There's an entire section on the docs for this. If you go to stenciljs.com/docs/methods, they dive into a little bit more detail into why this works, how the architecture is built to be asynchronous, and how you could eventually move your components API into something like a web worker. One thing to note is that they do suggest keeping your publicly exposed methods to a minimum. And if you are going to use a @method decorator, your method on the class must use the async keyword. So back in our editor, even though we are only setting a class property, we're still going to call this as async. Back in the browser, we can set a new value. And note that it's still going to work. Continuing with our list of decorators we can use, the next one is the listen decorator, which allows us to listen for events that either get emitted from a global context, from our component, from some other component, however we want to handle this. So we already have our first event. The event first name did change. And we emit that event whenever the first name changes. But what if we wanted to listen for when that event actually fired? To do this, we'll create an @listen decorator, and we will pass in the event first name did change, and then we'll create the method to react to this. Now, this also provides an event as an argument. So we can say console.log event did fire, and then log out the event here. So we can save our file, go back to the browser. Our component is selected. Go $0.first equals Mike. And now we're able to even further handle when things happen in our component. So now we have the on first changes being fired from the new and old values of first. But now we also have the event detail from our on listen handler. Here we can see we're still getting the same custom event that we got when we created our event. And the detail or the actual value that we wanted to set is being provided, listing Mike as the new value. Listen can also be applied to other elements that are not our own component. Let's create a new listen declaration, and we're going to listen for the click event, but we're going to set the target to window. We'll create our new method called on window click, get the event, and then we'll console.log window click, and then log out the event. We can save, go back to the browser, and when we go to click the window, we'll see the event type getting printed out, and we'll see the window click text from our console log. So listen allows us to target events within our component or from other elements outside of our component. Finally, the last little thing that we'll look at for our component is how to target a host context or target the component itself. Say, for instance, we wanted to set a class on our component that gets computed at runtime. To do this, we can come down to our render, and first we're going to wrap this in some parentheses, and then we're going to create a host element, which we will also import from Stencil core. We'll move our existing structure to inside of the host, and then we can start to apply different attributes or properties that will get reflected back to our component. For instance, let's say we want to generate a class name that would be derived from the property last. So we'll set a class prop on the host, which is going to be an object that we can return. And the first key that we'll set is last set. And the only way that this will get set is if this dot last is declared or set on our component. So we can write our file, go back to our component, and we can see we have the class is last set on our component itself. If we were to say $0.last equals null, the class will get removed while also updating our component in the render. Host can also be used to set the ARIA attributes of your component. So if you are building out a component set that you want to be accessible, you can start to specify the ARIA attributes using the host component. I wanted to touch on component styles for a moment. If we look at our component decorator, you can see that we are declaring that we're using Shadow DOM. And we can see this by coming over to our component, expanding the component itself, and seeing that we have this shadow content property. And if we expand it, we have the actual contents of our JSX. Now, we have this style element created inside of the shadow content. So any styles that we write inside of our component file will automatically get injected into the shadow root. Let's open up the mycomponent.css file. And you can see we're using the host selector to target the internal shadow root of our component. We can also do something like host div and then set the background color to, we'll do red. Write our file, come back to the browser, and we can see that that color is updated. Our styles are updated as well. And this is working as you would expect. If we update the index.html and include a div outside the component, so not part of the shadow root, when we come back over to the browser, we'll see that the styles do not leak. So this allows us to not only encapsulate the internal logic of our component within that shadow root, but encapsulate all the styles so that way nothing is leaking over and we can essentially create a private API for our component. Now, as far as building components with Stencil goes, this covers all of the different decorators that you would use and the different situations you would use them in. The real value proposition for Stencil at this point is not in building out the component itself, but taking this higher level abstraction of a component or the idea of a component and building out the framework bindings or the framework type information that you would need to run this component using React, Angular, or Vue. Let's dive into actually making a Angular specific binding for our web component. First, let's close our editor and then install the Angular output target package. We'll run npm install @stencil Angular output target. This is a new type of output target that is a add-on to the output targets that Stencil offers by default. So to configure this, we'll open up our Stencil config, and then we're going to import from @stencil Angular output target. Now we'll grab the Angular output target export, and then we'll come down to our output targets and create a new entry called Angular output targets and create a new object for all of the different keys that we can set. The first one that we'll need to set is the component core package. And this is going to be the package name for our component. In this case, since the namespace is set to TSConf, we'll set the core component package to TSConf. And then next we need to set the directives proxy file. This is going to be a path that Stencil will build a file to. So we'll set this in a moment, but what is directives proxy file? So let's look at our component again. Inside of our component, we have a lot of information going on about what type of properties this component can have, what kind of events this component can emit, and the different type of methods that could exist on this component. All this provides the correct type information that Angular can understand what this component does with a little bit of help. By providing a proxy or a shim Angular component, we're able to tell Angular all about the different types of inputs and outputs and methods that exist on our component by reading all the type information inside of this component file. So our directives proxy file is a file that exports all of the shim Angular components that the Angular compiler will be able to understand and provide meaningful output to our users. Before we set the directive proxy file, let's do some project maintenance first. Let's close this out. And we're going to go back up a directory and make a new directory that is going to be the base of our mono repo. So we'll make a directory called tsconf mono, and then we'll move tsconf itself to tsconf mono tsconf. And then we will cd into tsconf mono. And we have our component library set up here. Now we'll create a new Angular project, but we will exclude an application from this project setting. So we'll run ng new TSConf ng and pass in the flag create application false. This will essentially create an empty Angular workspace that we can add a library to. Let's open a new terminal and we'll cd into the TSConf ng. We'll run ng g lib tsconf ng. This will create a library scaffolding for us instead of creating the default application project that the Angular CLI defaults to. We'll open up our editor in the Angular project, and then we'll get a sense of what our project looks like. So we have this projects directory with this tsconf ng, and then a source folder with the lib, public APIs, and some component files inside of lib. What we'll do is set the directive proxy file to get built to this lib directory inside of our Angular project. So back in our other terminal, we'll cd into the Stencil project, open up our editor, and we'll go to the Stencil config and set the directive proxy file to build to up a directory in the tsconf ng project. And then that will get built into projects, tsconf ng, source, lib, proxies.ts. So at build time, whenever we invoke stencil build, it will build out this file. And when the build is completed, it will exist in this directory. So we'll write file and exit the editor. And then we'll just run npm run build. And then we can see in the output generating Angular library started. And if we go over to the Angular project, we can see that we have the Angular component lib utils folder and then this proxy.ts file. If we open proxies up, what we get is a shimmed Angular component that itself is a shim around our web component. In the @component decorator for our Angular component, we have the inputs and outputs mapped to our props and event names from our Stencil component. And then we use another decorator generated by Stencil to map our inputs and methods to the underlying web component and have them run outside of Angular's change detection. This way, whatever happens inside of the web component is contained to the web component, and all of the props or inputs are kept in sync with one another. Now, we still need to export this component and set up our Angular module, so that way consumers of this now Angular component can import it and add it to their Angular project as one would expect. To do this, we'll do some project maintenance real quick. Let's delete this spec file, this component file, this service spec, and then the service itself. And let's open up the TSConf ng module. Now, we can get rid of this import statement as well as the declarations and exports, as well as this imports array inside the ng module. What we can do is import from TSConf loader, and we can import a function, define custom elements. Now, this is a function that will go ahead, take the window object, and map everything back to our custom elements that we generated inside of the Stencil project. So we can call define custom elements and pass in window, and we can close it out. Now, we also need to import our component from the proxies. So we will grab the myComponent class, and we'll add it to the declarations inside of our ng module, as well as the exports. Then the last bit that we need to do is update our public APIs. We can remove the exports from our deleted files and then add a new export where we are going to export everything from lib and proxies. From here, the final things that we need to do is go to our package JSON and then add a list of a dependency to TSConf. And we'll just use a star for the version here. We'll also need to modify our ng package to add our web component as a list of allowed libraries that our Angular component can depend on. So for this, we'll just add a whitelist non-peer dependencies, and then we'll pass it an array with TSConf as the only entry. We can save, and then we can close our editor, and now we can set up to finally test it. Now, in a real production case, you would probably have a more sophisticated build system, something like Lerna or another approach to doing mono repos. In this case, we can just run npm run build inside of Stencil, and then we can run link to link our project to our global npm directory. Back in the Angular project, we can run npm link tsconf, and then run our build to build the library. With our build done, we now have a web component built by Stencil that we can ship to npm, and then a Angular version of our web component that is also built using Stencil and Angular's compiler that we could ship to npm and install in our Angular project. We went through Angular to look at the output targets, but there's more than just Angular in the output targets. We could also have support for React, Vue, and also Svelte. So if you need more support for web components inside of different frameworks, output targets are a great way to add that. So, wrapping up, we've gone over the core APIs that Stencil provides. We can create a web component using the @component decorator. We can declare properties that can be set on the component using the @prop decorator. @state allows us to declare some internal data that, whenever it changes, will cause a re-render. Watch allows us to react to when changes happen on internal props. Events allow us to emit data from our component. Method allows us to expose internal class methods on our component. And then listen allows us to react to whenever events happen from within our component or outside of our component. Now, Stencil is used extensively in the wild today. Not only do we use it inside of Ionic, but we have companies like Porsche, Amazon, and Apple who are using Stencil to build out component libraries that are used across their product suite. And just to recap, Stencil is a compiler for building web components. It gives you a higher level abstraction to author your components and reactive data with @props, JSX to author our component structure, and a one-way data flow where we can send data in using props and then emit that data using events. When we need to target other frameworks, we can use output targets to generate the framework specific bindings like React, Angular, Vue, or Svelte. So that's all for the workshop. I hope you've learned a little bit about Stencil and what it can offer. If you want to learn more, you can go to stenciljs.com. And if you have any questions for me, feel free to reach out. I'm Mike Hartington again, and you can find me online at mhartington. Thank you so much.